Hello and welcome to a Python Basics tutorial, where you can learn about the semantics and basic operations that lie within Python. To begin, we'll start with the print function, which is used to display information to the console. Here we have two print statements, hello world and 2024. And if we go over to the right, top right here, and press run, you can see that in the console we have hello world and 2024. The print function is also useful to help when debugging, to check the values of variables. Next we have comments. In Python, there are three different ways to make comments. The first is a single line comment, which always begins with a pound symbol. But if you want to make a multi-line comment, you have to use either triple single quotes or triple double quotes. This must be put at the beginning and at the end of your comment. If you want to comment sections out of your code, you can press the hotkey Ctrl+//. This can be used to comment and uncomment these sections of the code. Next we have variables. So what is a variable? A variable is a container that stores a piece of data. Here would be an example of a variable, with a declaration being the name of the variable and the data that is being stored as this value. In this case, it would be a string with the word value. But this equal sign is how you assign this data to your variable name. But there are many illegal declarations for variables. Here are some examples. To begin, variables cannot begin with a number. For instance, this 100 var would not be a variable. Variables also cannot contain spaces, dashes, or special characters. Here you can even see that the error we're getting is that expression cannot be assignment. But variables also cannot have a declaration that is the same as a reserved keyword. For example, for, with, and if cannot be used as variable names because they're already used for other operations. But we can change this by saying for var, for instance. This would be a legal declaration. But even with all of these limitations, we still have a lot of potential for declarations. There are three main cases though, or preset rules on how to name your declarations. The first is snake case, which all the letters are lowercase and every single word is separated with an underscore. Here you can see on line 26 we have an example of how a variable would be declared with snake case. We also have camel case, in which there are no underscores and every single word begins with a capital letter except for the first one. So you can see this is also an example on how to write a camel case declaration. And then we have Pascal case, which is very similar to camel case in that every single word begins with a capital letter, and this also includes the first letter. And this is an example of how to write Pascal case. So, okay, now we have declarations over, but how do we assign values? We use the equal sign, but there's also many other ways to assign variables. In this statement, we have x, y, z is equal to hello, 13, and true. And here we have three different data types, but we assign them separately to each variable. Here, x would be equal to hello, y would be equal to 13, and z would be equal to true. Now we can also assign one value to multiple variables. Here we have x is equal to y, which is equal to z, which is equal to 5. In this case, all of these variables would be equal to 5. X would be 5, y would be 5, and z would be 5. Next, we have the del keyword, which is used to delete variables. Here, if we type print x and we try to run it, you can see we actually get an error, name error, x is not defined. And this is exactly because we have deleted the variable and we try to access it, which is why we get an error, because x does not exist. Next, we have data types. So exactly what kinds of data can we assign to our variables? Well, to begin, we have numbers. So first we can have integers like 23, 85, 102, and then we have floats, which are numbers that include decimal places. So 10.5, 2.3, and so on and so forth. Complex variables are numbers that include complex numbers, and we use j as the complex number. The complex numbers can also look something like 2j. And then we have Boolean variables, which always must be true or false. We have string variables, which can be any piece of text of any length. And then we have list variables, which is data that contains other data. So here we have a list, which is a data type, but it also contains an integer, integers as data types. Then we have a tuple, which does the same thing. We have a set of names that we store in this data type. We have a dictionary, which is a data type that has key values and keys and values. Here we have the keys, name, age, and sex, and then we have Jacob 25 and male as the values to these keys. And then we have a set, which is also a data that contains other data, and then we have frozen set var, which is the same thing. And then we have byte array, we have byte variables, byte array, memory view, and then we also have none, which means that the variable is none. There's nothing there. So what are literals? Literals are examples of these data types that can be inserted into variables. So here you can see we have a number literal int, which would be a variable, but this literal is an example of an integer value. So we have a literal integer, and then we have a binary literal, which is a just consists of a byte. Then we have a decimal literal. Here we have a float literal, which contains this decimal place. We have a complex literal, which contains that complex number that I was talking about. We have a Boolean literal, which again contains either true or false. Then we have a list literal, which is data that contains other data. And then we have a non-literal. So here, going back to the numbers, this is an integer, this is a float, it contains a decimal place, and a complex number, which contains a complex number. So now we're going to talk about casting, or the conversion from one data type to another. Here, if we check the data type of this variable, you can see that we have 70, so it should return an integer. Let me press run, and you can see the class is indeed an integer value. But what would happen if we were to add 0.25? Well, we give it a decimal, and what happens in this case is that it actually turns into a float value. Now this is implicit typecasting. This is when we change the value of a data type, and by doing so we change the value of the data, and by doing so we change that data type. So in this case you can see we actually turn it from an integer to a float just by adding this 0.25. But there's also explicit casting, which is when we manually convert a variable from one data type to another. So here we have my cast number, which is equal to an integer value 7,234. But let's say I didn't want it to be 7,234 as an integer, but I wanted it to be a string, like this. That way I could just say print my cast number, and it would be a string. Now, this would also work if I were to do this, because print statement also works with numbers. But if I wanted to convert it to a string, I could say my cast string is equal to str, which is a keyword, and float, which is also a keyword. And then you put your my cast number as a variable within the argument of the string function. And if we check the values of my cast number, my cast string, and my cast float, you can see that here we have an integer, which is the original 7,234, and then we have a string, which is a converted string to 7,234, and then we have a float of 7,234. So this would be an example of explicit typecasting. Now we take a look at booleans. Once again, booleans can only be true or false, one or two values. But it is interesting to note that if you cast a boolean as an integer value, what you'll get for a true value is 1, and for a false value, you will get 0. So, little piece of knowledge right there. Next we have strings. So how do we assign a string? Well, you can use, much like comments, how you can use either double quotes or single quotes, the same thing can be done with strings. Here I have a variable that takes a single string, single quoted string, but we also can make strings with double quotes. So there is really no difference between using a single single quote or a double quote. The overall consensus is just try to remain consistent. So let's say we have a sentence here, but it contains an apostrophe. In this case, you would normally want to use double quotes, but if you are using single quotes, you want to make sure that you're using what's called an escape character, or the / character. And you put this in front of any apostrophes or any quotes within your string so that the string doesn't just take this part. Because if I remove the escape character, what you're going to get is that, and then the rest of the string is not counted for. So in order to make multi-line strings, again, very similar to comments, what you can do is use a triple single quote or a triple double quote. Now, this works for both cases, but once again, if you're using single quotes, stick with single quotes. If you're using double quotes, stick with double quotes. Just try to be consistent. So, the interesting thing about strings is that we can actually grab individual characters from a string, because strings are actually indexed. You can see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on actually represents the places that these characters lie on. Basically, sort of imagine this as like a number range. But if we, let's say, print my test string 4, what this does is this basically grabs the 4th letter within this index. So lorem ipsum dolor sit this string, begins with 0. It always begins with 0. So L would be 0, O would be 1, oops, O would be 1, R would be 2, E would be 3, and M would be 4. So if we want to grab M, we would be grabbing at index 4. And if we grab at index 5, we would not be getting anything. We'll be getting a space in between M and I. If we want to grab index number 6, we would grab the I letter. And if we wanted to grab 18, we would grab the second 18, which is right here. We would grab S. But the interesting thing here is when we get negative index, and Python can actually do this. What happens if we grab the negative index is we start from the back. So negative 1 would actually return the letter T in this case. And negative 26, well, the whole line is 26 letters long, so negative 26 would actually be L, because it would be 0. But let's run it and take a look. So you can see here, the first line, print my test string, number 4, it has returned M successfully. And then 5 returns an empty space, 6 returns an I, 18 returns the S, and negative 1 returns the T since it's going backwards, and L is returned when we get negative 26, which is the beginning. And we also printed the length of my test string. This function is also a reserved keyword, len, which is used to return the length of not only strings, but also like lists and dictionaries, and so on and so forth. So that is the length of the string. So not only can we grab individual characters, but we can also grab different sections from a string. Here you can see we have the same string as before, lorem ipsum dolor sit omet, and we have the same index, nothing new has changed. But here, when we use a colon, that means that we want a section of this text. So in this first statement, 4 colon, and then that's it. What this actually means is that it would go till the end of that string. So 4 to the end. If it were the other way around, it would be nothing to 4. And what this really means is that it really means just 0. So this would be grabbing from 0 to 4, which would be lorem. But if it were 4 to nothing, it would actually be to -1, because it wants to go all the way till the end of the statement. Now, something important to point out is when you have this second number on the right of this colon, it actually doesn't include this index. So on this statement right here, 0 to 5, it would really be getting 0 to 4. This 5th character is not included when you have it on the right side of the colon. So in this case, the second statement would just return 0 to 4, which is lorem. But 0 to 6 would not be lorem I, it would just be lorem with a space. 0 to 18 would return 0 to 17, because 18 is not included, so that means it would return lorem ipsum dolor with a space after. And negative indexes work pretty much the same. So it starts at -1 here, and then it goes -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. So it would start at L, lor sit ame. Notice how I didn't include the T, because once again, the right side of the colon is never included within when taking like a section of code. And then here we have -6 to -25, which would only include the L, because -26 is 0, and then -25 would be O, but since it's not included on the right side, it would just be L. So let's take a look. So, yep, as I said, 4 to the rest of the code, which would be here till the end, would be m ipsum dolor sit omet. 0 to 5, which would include this, would just be lorem with no space after it. And then 0 to 6 would be lorem with a space after it. And then 0 to 18 would be lorem ipsum dolor with a space after it, because it does include the S. And then -12 to -1 is lor sit ame. Once again, no T after, because this -1 means it's not included. Now, if we got rid of the 1, then ame would be included. Here you can see that we have the T at the end. But if we do include the -1, then the T would not be included. And then finally we have the L, which is the first value. Now the way you could also do this is you could just say 0 to 1. This would also return the L. But if you just wanted one character, then you can do what we did in the previous thing, which is just grab a single character from the index. Whoops, sorry, it should be 0. This would also return an L. And once again, we check the length, which is equal to 26. It's still the same string. All right. So you might be thinking, okay, if we can take individual characters and even sections of characters from a string, surely we can change the actual characters of the string. Well, unfortunately, that's not the case. Here we have an example of my first string is equal to hello world, and my first string, index of 0, I want to change it to G. So this would turn into gello world, right? Sadly, it does not. String objects does not support item assignment, and that's because strings are immutable, which means you can assign a variable a string, but once it's assigned, you cannot change individual characters. You could change it by saying my first string is equal to gello world. And in this case, if we print my first string, you can see that indeed we actually changed it from hello world to gello world. But in Python, we cannot change individual characters by using the index. One interesting thing that we can do, however, is string concatenation. What this basically means is that we can take individual strings and we can use the addition symbol and we can basically put them together. What this does is that it combines hello, which is this first statement here, and then we can add a second string, which is world. And notice that we've added the addition operator, but we also added a separate string in here that just contains a space. We can do this as many times as we want. We can add and beyond. And this would still work because in the print statement, here we have a string plus another string plus another string plus another string. And if we press run again, you can see that we've changed it hello world and beyond. Now we can also do string multiplication. When we multiply strings, we actually make them appear over and over again. So here we have my star string, which is just an asterisk symbol, and here we have my star string times 2, which means that we will be seeing this asterisk symbol twice. My smile string, which is just a closing parentheses, is then multiplied by 4, which means that we'll be seeing this string 4 times. And then we finally add it together using string concatenation, which we've just previously done. And what this returns is 2 asterisks and 4 closing parentheses, just like we intended. Alright, this has been Python Basics tutorial. You've learned a lot about variables, about the print statement, about how strings are assigned, a lot of the data types, and a lot of the declarations. This has been section 1 of a part series, and I will hope to see you in the next video. Thank you for watching.